I mean, this conference is called Quantum Theory with All Observers number 3. There were 2 conferences before, almost 7 years and almost 14 years back. And this is, I guess, the last conference of that kind of conferences with such title. The title comes from a quote from John Bell, who's also the leading personality, or let's say he gives the main ideas which were discussed here at this meeting, or will be discussed at this meeting. And I mean, I don't know, do you know, how much do you know about quantum theory?
Little.
Little, okay. Now, quantum theory has a long history of debates. And the debate, basically, this is a debate which goes over 80 years by now, almost 100 years. The debate is always about really the question, what is it, what quantum theory is about? And the traditional way of looking at quantum mechanics, or thinking about quantum mechanics, is always by invoking what is called an observer. The observer is a subject which is not specified, not further specified what it really is, but the observer is responsible for facts in the real world. Okay? Quantum mechanics, in the quantum mechanics, the main equation which we have is the Schrödinger equation. And the Schrödinger equation alone does not account for facts. The Schrödinger wave function, which is governed by the Schrödinger equation, does not account for facts. And to account for facts, one has to invoke this strange object, the observer, and the observer then creates facts by looking or by observing. Okay? So it's almost in a way as if things only exist because they are looked at. If nobody looks, things don't exist. Okay. And for a description of nature, for understanding nature in terms of physics, one would like to have a theory which does not rely on such an undefined subject like an observer. We would like to talk about what is there in nature and how these things which are there behave, which we call physical laws at the end. Okay, and this explains the title. What we discuss here are quantum theories which do not invoke an observer. Quantum theories which spell out from the very beginning what they are about, what are the objects of the theory, and there are various proposals on the market, and basically what we discuss here now is the status of the various proposals and how they stand to each other, whether they contradict each other, whether they, what are the differences of these proposals, and that is basically the main object or the main structure of this meeting here. In fact, when one discusses such theories, it is good that the main part of this conference is actually discussion. That is what is intended. We would like to discuss with each other. And there are very few talks, and these talks set basically the stage for what has to be discussed, what could be discussed, and that's the way it's structured. Yeah, well, we actually have a wide spread of specialists. They range from philosophy of natural sciences over physicists, over mathematicians, and, well, of course, we have theoretical physicists, mathematical physicists, experimental physicists. So actually, I think we cover basically all the fields which are connected to this kind of fundamental issues which are discussed, which I think actually is also something very unusual, that we have here a kind of platform where all these different ways of thinking about these kind of topics come together and to discuss. So experimentalists talk to philosophers and to theoretical physicists and vice versa. So I think so there's a kind of really interdisciplinary action going on here, which makes, of course, again, the meeting lively and fruitful. It's important because quantum theory is, at the moment, the fundamental theory of nature. Okay? So it ranges, actually, it should range from the microscopic to the macroscopic world. Everything, in a sense, is quantum. On the macroscopic scale, the world doesn't look very much quantum, it looks classical, but that can be understood as a kind of emergence from the quantum formalism, from the quantum theory. So it is the theory, actually, of the world. But now, since it's not understood what actually it is, what quantum theory is about, it's no theory of the world. It doesn't connect to the world in any kind of understandable way. That's because, again, of the observer, the role of the observer, which is an undefined object. So, I mean, I think if one adopts the idea that physics should give us all a kind of worldview which makes sense and which explains to us the world, and I guess that's what science is about, to explain what is there, how it behaves. At the end, if you take all science together, presumably why we are here, what's the role of us. So, I mean, it's important to have a view of the world which is understandable and which makes sense. And foundations of quantum mechanics just means that we try to find out what it is. What is the right quantum theory? What is it, what quantum theory is about? And if we have that, if we understand that, then we can say, now we have an understanding of the world. I think that's important, and I think it's good enough and justifies such a conference, and justifies also the whole idea of this cost action which we have to actually, in a kind of joint effort, to come to an agreement. Well, I mean, it looks like it works out well. We had lively discussions, heated discussions. That's good, because I think physics has a lot to do with emotions, with feelings, what is right, what is wrong. People always think that physics is a kind of objective theory, so emotions have no place in such a environment, but it's wrong, of course. I mean, we are all devoted to the theories we believe in, try to defend them, and so the discussions go on actually quite well. And I think also we clarified very many issues which were questionable before.